everyone. Thanks for coming this morning, and hopefully you can hear me online. If you can't, just let me know. Very warm welcome today to Yu Chang Wang, recent hire at USyd in the econ department, who's going to be telling us about trucks. Thanks, Yu.
Thanks. It's a great pleasure to be here to present one of our current kind of projects. So to give you guys a very quick kind of overview of my background, I was trained as an economist. I work a lot in transportation sectors. So I'm interested in transportations. I'm interested in climate change and transportation. Basically, I study how climate change impact transportations. Basically, this project is about. I also have worked to study how transportation impact or decarbonization impact climate change or pollution. So, I'm very interested in both. So today I'm going to share with you it's a very preliminary kind of a recent project. We work on how truck drivers respond to heat wave, or how do they respond when they exposed to extreme heat in the context of China. So
sorry. Put focus away from should work now.
Thanks.
Excellent.
Okay, so I feel like for the audience here, it is not hard to motivate that workers' exposure or on the workplace exposure to heat is an important question, because obviously there's a lot of evidence or surveys that heat wave, heat shocks generate a lot of workplace accidents. There's a lot of risk involved with it, and as economists, we care about productivities, their performance loss. So there's a lot of negative consequences when workers exposure to heat, and this across a lot of kind of different fields. In this project, we care not only their kind of the negative consequences of exposure to heat, but also we care about how drivers or workers respond to it. We call it adaptation. For example, just very natural example in the case of truck drivers, when you can think about truck drivers stay in a small driving cabin for more than 10 hours a day in a very humid tropical kind of area, and how do they respond to that? There's several options on their menus. For example, they can turn on AC, right? They can take a rest more or for a longer duration, or they can even change their if feasible, they can change their labor supply schedule. Maybe, for example, I just not working today if it's too hot, or I just postpone my starting working time. So there's a list of kind of approaches they could choose from to adapt to that. So the first question, empirical question we wanted to kind of answer in this project is how to measure that and how to respond to that. So why this is an important question? Why we want to study this question? Because as far as my knowledge, currently the empirical evidence from the field, I'm not talking about the lab, but from the observational data, to measure adaptation or the direct evidence is still limited. The reason is straightforward. It's hard to observe. It's very hard to get data on that. I will elaborate a little bit more on that. So the thing is, the outcomes, the negative consequences are commonly observed. For example, their accident. You can get data from the crash report, for example, but the instant or the real-time response is very hard to observe, and also their adaptation behaviors. So this is the first challenge of the literature. And another natural question is our economists care about is do they respond to that efficiently or enough to kind of mitigate or adapt the negative impact. We do not have unfortunately a lot of evidence, but we have a lot of anecdotal evidence that they are not likely to respond efficiently or enough to heat for a lot of reasons. Probably because there are a lot of information frictions. They are not even aware of that, or psychological reasons, et cetera, et cetera. So it is important to understand, to measure that. And in the third part, of the last part of of this talk, I will try to I will if we have time, I want to share some interesting result to understand the role of their employers in this whole kind of stories. How can the employers shape their adaptation behaviors? So basically, the takeaway what I'm going to do today is I will first show you how they respond, and second, how would their employers could potentially change their adaptation behaviors. All right. So I think I already briefly touched upon that. This is for the economists using observational data in the field. It is super hard, at least from my knowledge now, to directly study the adaptation behavior. So this is the challenge in literature. The reason is straightforward. Typically you can think about this is kind of a trajectory or the logic link from heat exposure to the outcomes, right? So think about the truck drivers. The heat, you can measure that. We have a lot of satellite data. There's no problem. We can observe heat. And then when the truck drivers are kind of exposure to heat, they might kind of feel uncomfort, for example. But you cannot easily observe that directly. So this part you cannot directly observe. And if they feel like uncomfort, for example, they will naturally respond to it. We call this adaptation, right? Most of the case in the current study, you cannot observe that. But what you can observe is the outcomes. The problem is the outcome is a function of all the three things. And it's a function of course, the outcome depends on the heat, but also it depends on how people respond to heat. The problem is you do not observe that. This is the nature of the challenges of the whole problem. We are talking about the field. I guess in the lab, it will be more feasible to directly measure people's real-time response. As an economist working with field data, it is very hard. So what we are doing here is we find a pretty clever way that we can measure that in the field. I will explain in a minute what do I mean by that. So basically, what we do in this paper is we kind of think we can bypass that. We can directly observe these two piece in this kind of whole story. This is that enable us to bypass kind of the current the problem or the challenge in literature. All right. Okay. So how do we do that? So let me briefly jump into first the background to give you a broader sense of how heavy duty transportation industry in China looks like. So heavy duty transportation in China account for about over 70% of the total freight volume. I guess even higher in Australia, or because we can't allow it on the kind of on road transportation. So heavy duty truck is itself an important sector in the whole economy. It's kind of it's a link the upstream and to downstream of the whole economy. So this is per se a very important sector. In terms of another reason, heavy duty truck is important because they are very dangerous. Give you a sense, in China, this is data from China. They account for 8% of total vehicle volume. However, they contribute to over 30% of the fatality in transportation. So basically, they are very dangerous. And it's not just a matter of accident rate, but it is based on the US DOT estimates. On average, one truck driver killed in the traffic accident, 5 other road users, innocent road users, also killed, because of we call it negative externality, because they are very dangerous not only to themselves but also the other road users. So again, the takeaway here is that heavy duty truck very 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 dangerous. And in China, another problem is that they typically work very excessively long time. For example, in our sample, the average driving time is 8 hours per day. Driving time means hands on wheel, right? But they stay in their driving cabinet much more than that. Actually, for example, in our sample, we can observe that they stay in their driving cabinet. For sometimes they can over 20 hours a day. So basically, they have a bed in the back seat. They just modify the back seat with a bed, so they sleep there. So the working time is super long for the truck drivers. And the exposure to heat problem makes the exposure, heat exposure issues very severe for them. And this is the background knowledge of the whole overall of the industry. And what about the data? I want to like to tell you how we kind of bypass the challenge I mentioned in the very beginning. So again, as I already mentioned, the key challenge is that we cannot in real time observe drivers' behavior for most of the previous observational data. To bypass that, one thing you could do is you can in the field. One thing you could potentially do is you keep watching them all the time, right? Like a big brother. Particularly, most of the cases is illegal to do that. And what we do here is we find contact with doing that is legal. What do I mean by that? So let me directly jump into. We work with a company, a tech. They call themselves a tech firm. What they do is they install sensors on the trucks. And why do the truck drivers or freight company want to do that? Because in our context, the government compulsorily request all the commercialized trucking fleet you have to install a camera pinpoint the driver's face and to upload the data to the kind of a centralized monitors. Because the reason is exactly because the truck is very dangerous. So to monitor kind of the real-time location and response behavior of truck drivers, the local government compulsorily require them to install that. And we work with basically an outsourcing company doing that for the company, for the government.
So is that throughout China or just one region or just one company in one region?
It's one company, one region in China. It's not the whole. I will mention that in a minute. And what they do, basically, they have two sets of data. One is GPS. This is already pretty standard. It's a real-time GPS reader. We know, the speed, where they are. It's a 24/7 kind of information. So this is nice because even if the truck driver is not in the driving cabin, we know they are not working. So we can directly measure labor supply using that information, even if they are they stop moving. And we know where they take a rest from the GPS read. If they, based on our algorithm, if they stay in some place for like say 1 hour or 30 minutes, we know they are taking a rest, for example. And they also install kind of sensors. They have two types of sensors. One type of sensors is kind of the outside to detect blind spot. Like this, right? Install something here to detect blind spot or line drifting or line departure or following too close, speeding type of thing. This type of sensor is already commonly used by a lot of insurance company nowadays. What is unique here is we have a camera pinpoint the driver's face, legally kind of compulsorily requested by the government, and we real time their kind of basically face kind of how they behave. And they use we work with the company, we use machine learning algorithm, use face recognition algorithm to detect what they are doing. For example, if we observe a driver with mouth widely open, we know they're yawning, and the yawning we believe is a direct measure of the real-time fatigue. And we know if they are using cell phones or they're smoking, we know we classify them as distracting. So this unique measurement allow us kind of to directly measure real time how they behave basically in the field context. And we have a pretty large fleet. We track 10,000 drivers for over 2 years. So it's a huge kind of the data. So basically, what I'm showing you here is we have two set of measurements, right? We know where they are, their speed. We know their real-time behaviors. Yes.
Are they fined or anything, or is their behavior monitored in a way that?
Are they aware of that?
Yeah.
Yeah, they are. Of course, they're aware of that. Yeah.
But I mean, like, is it in a way that's enforced? So they could have this data, but I mean, 2 years time, that's probably a pretty good way for people to have normalized having the camera in their truck. right? So, I mean, initially, maybe people even could have moved away from, that region being like, oh, I'm not going to be tracked or something,
I
but
feel like it is enforced pretty well because this is the truck drivers doesn't want to, maybe they doesn't want to have that, but their employers, their trucking company is compulsorily enforced by the law basically. So this is well enforcement, and actually this is an interesting. So how we can work with them is because they have a big chunk of data, right? And what we kind of offer the company, not the freight company, the data company, is that we can use their data to generate some performance evaluation we help them to generate some performance kind of report for the drivers, for example, and they can solve that as a evaluation to the trucking fleet.
During the time that you're studying them, is their pay linked in any way to this kind of thing?
Unfortunately, no, we do not have, because again, we do not directly work with the flight company. So we try to do some follow-up study to survey the truck company, but because the major data vendor is not from the truck company, it's a third-party company service the truck company. So they only installed sensors, they do not have the payroll, for example. So it's hard. We currently do not have that information.
Oh, so you don't know if the freight companies are using these cameras to base their salary or anything?
We don't know, but we asked them if they, we're almost pretty sure they do not use this performance based upon their wages. But we ask we survey some freight company if they, as a punishment, for example. But most of the wage, and I will mention that in a minute, the wage scheme of the truck industry is pretty standard. It's pretty much like kind of a piece rate kind of structure. So the heat data is already pretty standard. It's from satellite. So the nature of the data is that it's a hourly level, pixel by pixel, kind of satellite images. We know the temperature of each pixels. And the thing we want to mention, because Tim asked that, it's only one region. It's called Guangdong province in China. And the reason we choose that region, or not we choose, I guess the advantages of study that region is because it is the hottest, the most kind of tropical region in China. So that's why, when I show you the results, we were fairly more confident about the impact of heat, but we are less confident about the impact of cold or it's frozen, because there's not really a lot of observation for the frozen part, because it's a very hot region in China. It's a good kind of context to study heat, but not for the cold. And we add a lot of kind of controls like air pollution, air qualities, or road conditions, or UVs. We all synthetic this information from the different satellite of sources. All right, and I will be really quick on how. But this is I regard myself as applied economist, but this is kind of we spend a lot of time to this is to teach ourselves how to work with this unstructured data. So this is what we learned. I would like to share with you. So basically, this is the satellite data, right? This just the raw data is just pixels. With the different color means you can think about the temperature in a specific hour. The problem is that how we combine this with the truck data. Basically, the truck data is something like this. Every 20 seconds, we have a geocode, right? We know where they are. It's a dot. And whenever there is something, if they're yawning, for example, if there's a red spot, we have additional red spot as a warning. So we have a lot of dot. The way we construct the heat measurement is that we connect this dot, right? And we overlay this kind of line segment. We overlay these routes with the base map from satellite. And we use the length of the line segment as a measurement of heat exposure. We have different measurements. You can think about, how long is it, right? Or how the duration of you stay in this particular you stay in this particular pixel in this particular hours. But there's a lot of way we can do with that. But the general idea is that we overlay this kind of routes with the pixels and allow us to measure a very granular and detailed exposure to heat. For example, we know for this particular driver, right, Yu Cheng driving the truck in these particular hours, how much second you stay in a particular time being, for example, between 30 to 33 Celsius degree, or how what proportion of this particular hour you stay in extreme heat being like above 33, for example. So we have a pretty accurate or at least granular measurement of the whole distribution of heat exposure for that driver over 2 years. Okay, so this is the empirical model, but I will jump it because I think I already explained the intuition of the whole exercise. The empirical model is just the implementation of that, right? So we just regress. We just compare two drivers and think about it that way. One happen to expose to, you spend, for example, exposed in 1 day. Driver A spend, I don't know, 3 hours in the extreme heat beings. And driver B, for whatever reason, spend like just 1 hour. So we can compare the relatively performance for that driver A and driver B in that 2 days. And we just implement that using this kind of standard regression model, right? Okay, so let me first jump into some results. So the first result I want to show you is that before the adaptation results, I want to show you does heat even generate any negative consequences, right? The first step, first order question. And so this shows you the impact of temperature exposure on the number or intensity of dangerous driving behaviors. Dangerous driving behaviors here is measuring by the warning we detected using those sensors. And we measure in the number of alarms or number of we call it warnings per 100 kilometers as an intensity of the how likely you are making a mistake, basically. How to read this kind of coefficients or how to read this result? Let's just look at the worst being. For basically the interpretation is that we find with an extra hour exposure in this above 33 Celsius degree beam, the number of alarm intensity increased by 0.4, which is about which amount to like 3% of the overall. Basically, you are 1 additional hour of extreme heat exposure, you are more likely to make 3% more mistakes. This is a very nonlinear, as you can see, a relationship. The more heat exposed, the bigger in terms of magnitude. So this is just the first of, yeah.
You've probably thought about this, but probability of an accident or an alarm or something is going to be correlated with traffic density.
Yeah.
And that'll probably be correlated with the time of day, which is correlated with temperature.
Yeah.
So there's a fixed effect in your model or something that's.
Yes, so that's a great point. So the quick answer is we in the baseline we include day of hour phase effect. We include day phase effect, and we control the traffic speed directly as a control, because how far basically your speed is a direct measurement of the how congested it is, right? So we control that, and we also try a lot of different specification, including that to control for that. That's a great point. And there's some heterogeneity effects pretty interesting I want to share with you. So left panel shows you that if you are more exposed to the heat temperature, the effect would be the negative effect would be less. Basically, we call it acclimatization. Basically, if you are already used to heat, you will be less impacted by the heat exposure. And if you are if you're a better driver, basically, you are less likely to be impacted by the heat. Driver or not mean the baseline, using the baseline kind of the temperature being whether your chances of making a mistake below or above or below the median. Basically, this takeaway here is that we find that heat make people drive worse. But if you are a good driver, the impact is likely to be smaller. If you are already, if you historically you drive a lot in the routes with high temperature exposure, you are less likely to be affected by that. Okay, so then I show you results on the kind of accident, making mistakes or dangerous driving. What about labor kind of productivity? Because as economists, we care about not only the chances of making mistake, we care about the performance or productivity. Here, we use two direct measurement of productivity, because in the nature of transportation industry is that the longer you drive or the more hour you work, basically the more economic value you produce, because this is almost a certain piece rate type of thing. The longer you drive in a day, the more delivered kind of tasks you're likely to achieve. So we use the number of kind of total driving distance and the number of total driving hours as an outcome, and we find a pretty substantial impact of the heat on decreasing the productivity of individual. So basically, the heat makes you drive less and working less hours at individual level. So this is a direct measurement of their performance.
I'm just thinking, so if I owned a trucking company, I would just simply say, well, they'll get used to the heat after a certain amount of time because those drivers who are more accustomed to heat.
That's a great point. That's exactly the next slide. Okay. So I already told you that in the individual level, this is a very large negative impact. But what about at aggregate level? If we aggregate thing to a company, will company do something to respond to that? If yes, basically the hypothesis is that if we observe the same negative consequences at company level or firm level, basically they're doing nothing, right? They just pass through the individual level kind of negative impact. But however, if we respond no effects, it must be they do something to adapt it or respond to it, right? And this is exactly what we find. We found no evidence that company level exposure to heat, average exposure to heat, reduce their productivity. But why is that? So what adaptation approach they use to achieve that? And we find that when there's a heat day, they just send more drivers. So the idea is that they are not necessarily even realize the underlying mechanism as I explained to you guys, but they know real time where their drivers are. So for example, they know you are lag behind than your today's schedule. They might not even know what's the reason, right? They don't care. They just know they do not know it's because of the heat. We know that because we're economists. We do the formal analysis. They may not even know that, but they still respond to that. Maybe you are like behind. Okay, I have to send another driver to do your next job. So at overall company level, we do not find any negative impact on their productivity measured by the total kind of driving distance at company level. But we do find that they respond to the heat.
So you could calculate the cost incurred as well.
It
There will be a cost. Yeah.
Productivity potentially that captured, but in terms of
cost benefits, it's whether worth it to send another.
Accounting perspective, that might be.
This is from the accounting perspective, we can calculate the cost. On the but the problem is we survey some company from their main side, reputation, or they can deliver on time. It's much more than long term. This is much more than I have to send another extra drivers, which I have to pay his wages. So it's much more important for them than that.
I'm sorry. So I've still got a question though, which I don't think this slide answers, because in 2 slides ago you were saying that a driver who's more accustomed to the heat isn't affected by it.
Yeah.
So couldn't you just argue, well, over time everyone will become more accustomed to it? Not that I necessarily agree with that, but couldn't you argue that based on your data?
We could, but I feel like you're exactly right, because there's evidence of kind of a climate.
I mean, there's still an uplift.
Yes. So we believe that you cannot perfectly partial out the negative effect, even if you are a very mature or experienced driver. Just do that.
Yeah.
Okay, so this is the second result I show you. Basically, in summary, we find that very large individual level negative impact on productivity, but very small aggregate firm level. And we basically our argument or our hypothesis is the response to that, and we show some evidence is really response through the more drivers. Yes.
So I've just got another question. So in China, do companies have to do climate reporting or climate-related financial reporting?
That's a great question. As far as my understanding, for the publicly listed company, they need. Yeah. Probably need. But for we're talking here is not that.
Sure.
Very small. Like.
But there are so many companies when you ask them, how are you exposed to climate risk? They will say, oh, we don't have any evidence of being exposed, but this is an example. Once you start matching up historical data, then it's actually there in there.
That's exactly, I guess that's why I mentioned, I guess most of the company in this study doesn't even realize what's going on.
That's right. And I think that's often the case. So I think this would be interesting for an accounting audience as well.
Oh, I see. That's a great point. Because that's pretty funny because after we finish these studies and circulate a little bit in for Chinese audience, there's another company, come to us, want us to use because they are like deliver a lot of kind of package parcels.
Yeah.
And they started aware of that. And they want us to do a calculation using their data because they already noticed that, when the extreme heat day, a lot of parcels, just like Amazon delivers, they burn themselves, literally burn themselves in the back trunk because it's very hot. And this paper box burn themselves. And they start
self-combust.
Yeah, still combust. And they saw studies and they want us to kind of calculate what are the chances of that happen.
How many companies, on just like a rough understanding, are in your data?
And here, this 130 companies.
It's 130 specific freight companies.
Freight companies and
10,000 or so drivers.
10,000 drivers, and there are some big ones. There's some big. I guess the largest one have about 1,000 trucks. Smallest one, we trim a little bit, have a slightly above 10 trucks.
The temperature, is that the internal cabin temperature or is that the external temperature?
It's the external one. So this is the one of the potential limitation because we do not have a thermal kind of measures inside the cabin.
Okay, because you would assume that they would have air conditioning.
I will talk about that in the next slide. So I hope I already show you some results that they basically the heat do have an impact. This is the key takeaway, right? Before I say anything about adaptation, like I have to first convince you that heat do have an impact. Otherwise, yeah.
Well, there's an impact, but I don't know about the magnitude. Like you don't. Do you know the standard deviation of these variables?
The only magnitude I show here is that basically you can think about this, right? The 1 extra hour of this is normalized by the mean, not standard deviation, but basically it's 1 hour exposure to heat increase the chances of making mistake by 3%. I regard this as a pretty large effect.
Do you have what that translates into actual fatalities or crashes?
I have that in the paper actually, but forgot it because we convert that to the crashes and adjust it by the VSL, the value of kind of statistical life, and to get a number. I forgot that it's actually in the appendix. In the abstract. I forgot the exactly number at this top of my head.
So that temperature bin of over 33. At the bottom there, you give us the distribution of the variable.
Yeah.
And the mean is like very close to 0. Are there actual observations where they're going over an hour a day in this bin because your marginal effect is an extra hour? Do you ever observe anything close to that?
I feel like the number of hour average is slightly above 3 hours, right?
No, I'm sorry, above 33. So the far right one.
Oh, I see.
This is where you get the really big one.
Yeah, you're right. Yeah, it's this one. Indeed, it's very. It's on average very small but you have to remember this is average.
Zeros.
There's no zeros. So it's average over the year. So you have it's kind of being averaged out because of the the winter, for example. So I could report another version of this with just summertime. For that, I pretty sure the number of it's definitely above 1 hour.
Right. So there'll be plenty of observations where you are actually going above an hour. Cool.
Yeah.
That makes sense.
Or just daytime?
Yeah, daytime. Yeah.
Because most of it's going to be at night.
Yeah, exactly. Okay, so of course the natural next step question is that do they respond to that, right, or do they adapt to that? A natural way is using air condition, right? And let me first directly talk about, before I jump into that, let me directly talk about two type of company we have in this context. So this is not just in China. In general, this industry have two type of labor contract. One type we call it employee. Basically, you can think about the truck drivers for calls on Volvos. The truck is owned by the company, and the drivers are themselves employees. So they are paid with kind of wages. And importantly, the company, think about like Coles and Woolworths, they pay all the operational costs, fuels, like salaries. They're all paid by the firm. Another type of company here is, we call it contractors, or your owner operators. Basically, I own the trucks myself. I just work for the freight company as outsourcing. This is pretty common in the whole heavy duty truck industry. So the key difference is here was operational cost. Why is important? Because for the employees, the operational cost is paid by the firm, and for the contractors, they're paid by themselves. Why this is important? Because I'm going to talk about AC usage, and surprisingly, actually, for this kind of heavy duty trucks fueled by diesel, turn on AC is very expensive. To give a sense on that, the operating cost account for over 45% of overall revenue. Half of the revenue is including, your food, accommodations, fuel repairment, fines, or et cetera, account for 45% of total revenue. And out of this 45% of operating cost, fuel costs account for half of them. So basically a quarter of the overall revenue goes into the fuels in this kind of industry, because heavy duty truck is very low fuel economy. It's very kind of polluted. What about turn on AC? Turn on AC for cooling is very expensive. To give you a sense on that, there's a lot of engineering studies, or based on the guideline of the US DOT, EPA, for those low fuel economy vehicles, turn on AC could increase the fuel consumption by 25%. So meaning for those kind of truck drivers, turn on AC for cooling is pretty expensive. Turn on AC for heating is not, because for turn on AC for cooling, you have to turn on the condensers, and instead of using the remain heat from the engine, that's why for the heating is not expensive. For the cooling is very expensive.
Sorry, low fuel economy vehicle. What does that mean exactly?
It means like trucks.
Oh, okay. Yeah. 25%. Wow.
Yeah, high fuel, like think about hybrid vehicle, Toyota, Peru, a Camry, something like that. This is kind of light duty vehicle, and heavy duty vehicle typically fuel economy means mile per, in the US measured by mile per gallon, but.
And this is just for AC for the cabin, because a lot of these trucks, I imagine, are cooling the contents already.
Yeah.
I'm just shocked that it could be so large just for cooling the cabin in a huge vehicle like that. But I'm sorry, I'm not saying you're wrong. I'm just surprised.
Yeah. So it's a wide range, as you can see, and this is just for, because there's a lot of different kind of type of trucks. There's tankers, containers, or just flat trial. Flat trial doesn't have a kind of a refrigerator, but still it goes up by 20-25%. So let's just take a lower bar for the estimation. So the takeaway here is that turn on AC for good adaptation come with a cost. Basically, this is the takeaway. The adaptation turn on AC is not come for free, but what that really matters is who pays for that. For the employees, it pays by the company. So for the contractor, it's paid by themselves. So I guess a natural hypothesis is that they will use kind of this as a adaptation, but who are using more? Hypothesis employee, right? Because they don't care about that.
So the firm is probably tracking how much fuel they use from A to B.
Yeah.
So the cost might actually be higher for the employee because they risk getting punished or.
That's true. So this become an empirical question either way, right?
Yeah.
This is the empirical. It's a matter. I will show some theory in the end to rationalize that if we have time. But they could, let's say, other than AC, there are some other type of adaptation approach on their menu, right? They could take more rest, for example. And they could just, for example, being absent today, I just take a day off, for example. There's a lot of other ways. So then what really matters is how on there they have a menu, right, of adaptation. AC, rest, labor supply, change their labor schedule. It's a matter of which one they choose, right? Based on the bang for buck. And I'm going to show you that this is for the third results of this study. How we measure AC? Unfortunately, we do not have direct measurement of the thermal and AC usage. But interestingly, because we have a camera pinpoint to driver's face, most of the time this kind of a camera can capture whether the driver's side window is open or not. Because the hypothesis is that if the window is open, it's very likely you're not turning on the AC. So we train another computer vision algorithm to detect whether you're using AC. Basically, the window is closed or open. It turns out it's not a very hard thing for the computer science kind of algorithm. There's a lot of off-the-shelf kind of algorithm. So we use window open as a kind of you can think about inverse measurement of turn on AC using AC usage, right? And this is what we find. This is a little bit noisy result, but generally speaking, you can find that for the contractors, the blue dot, they use less AC when the heat exposure goes up compared to the non-contract means company drivers. So this is generally speaking, and from the statistically, I can tell you this is from the estimation is a statistically significant difference. And so the takeaway here is that consistent with our hypothesis, in terms of just AC usage, company drivers use more AC in response to heat than non-company driver or contractors. And one of the hypotheses, the reason is because, as I already explained to you guys, the company pays for that. So why should I care? Basically, in some sense, yeah.
You're saying the difference is statistically significant.
Yeah.
But they're like wholly within each other's confidence intervals.
That's true. So
in a bunch of the buckets anyway, not all of them.
Yeah, that's true. So this is from, I guess this specification you see here is a very strict, you can think about it, it's a very conservative estimation approach. If we are reporting the table, it's kind of one of the reasons is we have very huge observation. So it still gives us kind of statistical power to do that. Yes.
Well, I was going to ask a related question. So is the uncertainty independent between each plotted point? What people often do for epidemiological studies and so on is they'll fit polynomial curves.
Yeah.
But then if you evaluated a bunch of points, the error would be highly correlated. But in this case, it looks like you're binning the data or something. Does that mean that we should regard those as independent?
If
they're independent, then I would easily believe that that's a significant difference because they're all below. The gap is consistent.
Yeah. So my take is that we are using a more like, you can think about more a non-parametric way to fit this kind of non-linear. And we could use like linear fit, for example, right? You mentioned those studies. We could use quadrangle. We could use different type of kind of order of polynomials. Here we essentially use we bin the data is a more a non-parametric way. The idea is that we could, as a robustness check, we could bin the data in a different way. So that give us the model or the pattern or freedom to feed the data. Instead of just imposing it has to be a curvature, the curvature of the fitted line. Does that make sense? Yeah.
Can you explain what's happening at the lower bound here when it's a cold day?
That's what I'm wondering as well.
Because your window's closed either way if you're putting on the heating. So it's going to be hard to detect heat usage.
So can I explain? Can I say that again? The question.
Yeah, exactly. So here the difference is it looks like a non-contractor and contractor have different behavior when it comes to heating. However, because it's a cold day, you won't be able to detect heating based off of your open or closed window. Clever hack.
Yeah. So I'll have two kind of response to that or question. Basically, like again, we focusing on this part, and as I mentioned in the beginning, for the cooling part or the cold part, this is not really cold. 9 Celsius degrees. So we do not have a lot of statistical power to say that. You can think about you can see the kind of the confidence.
Depends on your definition of cold.
What?
For some of us, 9 degrees.
That's less than 10. 10 then I know that
Right.
calculation
Yeah.
to Fahrenheit, that's
Put the heating
50.
on at 9
Yeah.
degrees.
So if you think about this kind of a U shape, in generally speaking, it's the U shape is that the non-contractor is always above the contractor, right? So it is basically the takeaway here is that no matter if you call it, let's just call it cold, right? No matter it's cold or heat, generally speaking, on average, company driver use more AC. That's the takeaway from a more suggestive kind of evidence. No matter if it's cold and it is just we are more confident about our results on the hot side than the cool or cold side, whatever we call it. So this is the first evidence. Again, this is a not perfect measurement. As I said, we do not have direct measurement of AC, so we have to train this kind of algorithm to detect that. So this is not perfect, but hopefully I provide some evidence, not maybe definite evidence, but to show that they do use AC, right? This is the first takeaway, and their behavior differentiated based on whether they are employed or they have to pay their own cost.
Do you observe their fuel at the start and end of trips?
No, unfortunately for this study, we do not. We have very limited information from the company side for this study, because again, we do not work with the company directly. We wish we could, but this is the limitation of this study.
Does the company know that the data company is selling or giving their data to people all around the world?
They do not directly know, but since we surveyed some of them, so for those companies we surveyed, and they definitely know that, but seems like they do not care much about that. Because again, as I mentioned, we offer the data company to provide some consulting kind of thing for them to provide weekly report, for example, to the. So they definitely know someone using the data, not necessarily us, but they definitely know someone using the data.
Yeah, they put okay in the terms and
conditions. Yeah, I know. This is the fine print. This is my
And real quick, what are the other results? This is the number of this is a rest, right? So let's for the sake of time, let's just focus on this. So this is the number of short rest, we call it the rest per 100 kilometers. And still, so two takeaway. One is you see when the heat exposure goes up, you see more kind of rest are taken. So this is a first direct evidence of they use rest as a response to heat. And what about the difference between the two lines? Actually, if you compare this one, it's flipped, meaning company driver now use less rest compared to the contractors. So in that sense, these two type of adaptation approach in the jargon of economists is kind of a substitute. They're substitution kind of a way. You don't have to do both, right? You just choose which one you want. And it turned out that the company drivers, they just choose use more AC, and for the contractors, they just choose to use more, like just rest more. And what about another? We have a third type of adaptation. We call it labor supply, right? What about this? Even more extreme. For the contractors, they reduce their labor supply, or basically, for example, they take a day off where they start working late. If you look at the blue dot when there's a heat, but for the company drivers, they never change their labor supply. Why is that? Simple. It's just company do not allow them to do that, right? So again, this is compensate to start. We already have. There's a menu of adaptation approach you can choose from. The company just choose to allow their driver to use AC, and the contractors, since they have to pay their own price for using AC. So what they do, because if they feel hot, they rest more, or they just take a day off. For the company, the on-time delivery is very important for the reputation. So they cannot afford you to take a day off or something like that, or use heat as excuse for shirking, for example. So there must be. This is a review preference argument. There must be some restrictions or rules within the company. You cannot use heat as an excuse for taking a day off, for example. Or you cannot take a day off at all. So no matter what reason. So, and what about the consequences? So I already show you, they pretty much different approach to adapt to heat, right? The company driver use more AC, contractor use more rest, labor supply chain. And who are more likely to be impacted by the heat? And this result show you the consequences. This is again the outcome here is the number of mistake making. I already show you, when the result when combine the sample. Now I just separate the two samples. You still remember in the baseline, the average impact of one extra hour heat exposure is 3% increase. For the contractors, it's about 4%, and for the non-contractors, it's about 2%, basically double the non-contractor impact. The negative impact on non-contractors almost double up the impact on the contractors. So one of the very speculative consequences we could draw from is the use of AC is more effective in some sense, right? Because if company driver use more AC and they are less impacted, so must be using AC more. Perfect. So that's pretty much since I have 4 minutes, I guess this is pretty much all for the empirical of the evidence I want to show you from this study. And since in the paper, I also explain the hypothesis or story we have in mind behind this kind of observed heterogeneity response to or adaptation behavior to the climate change or to the heat, right? So in the paper, what we do, one more step was I developed kind of a theory, economic theory model to explain why, think about you are a owner of a company, right? Why you choose this kind of adaptation approach instead of the other? What's the main side behind that? So to give you a very high level of the intuition, you can always choose whether to use AC or to allow your driver to take a rest. The benefits is straightforward, right? No matter which adaptation approach, the benefit is to reduce heat risk and performance loss. Straightforward. But there's always a downside, and in the economics we call it moral hazard. What does it mean? For example, if I allow my drivers to use AC, there's a potential that since I do not pay, as a driver, since I do not pay for my AC usage, why not I just turn on the AC all the time? I just overuse the AC. Or I just like AC, and no matter I really feel cool, I just keep turning it on. It's called overuse or moral hazard. And this issue is even more severe if you allow your drivers to kind of take a day off when there's a heat, right? Because I can always use that as an excuse for shirking. For example, I just feel like I don't want to get up today, and I just email my kind of manager. I feel like it's too hot today. Can I take a day off since we are allowed to use this as excuse? If the company have this kind of rules, so in the model, basically in the theory, it must be the case that for the company, the risk or the moral hazard risk from overuse AC is much more easier to handle or less of a problem than they use heat as an excuse for resting or changing labor supply. They cannot afford that, so that they choose AC. So we have a more formalized kind of theory for that in the paper, but I guess the general idea is this, right? So that's pretty much all for the presentation. And in a quick summary, basically we study this kind of a heat exposure, right? Using observational data. This is one of our contribution, because there's some already existing some lab studies. So we use field data that we can allow us to directly measure exposure, and we do find first there's a negative impact of heat. Second, they do respond to that using adaptation. Third, how they respond to the adaptation is really different by whether they are a company driver or they own their own trucks. Okay, that's pretty much all for my presentation. I hope you enjoy it, and I'm happy to take any questions.
Thank you.
Thank you very much. That was great. The consulting project where you're using the videos to track their performance sounds horrific, but this was really interesting.
Thank you.
So that's 11:30, so that's it. And please stick around to ask questions.
A lot more questions.
Did you say that you were in contact with the trucking companies or? So because you've got the data through the company that has the tracking, collects the tracking.
Yeah. Third party.
But are you in contact at all with the trucking company?
Some of them, not
So
all.
they might be interested in this information, I assume.
Yeah.
Are you able to get their financial information, like around the costs and the operational cost?
Probably we can ask, but it will become you guys can imagine it'd be more.
They're mostly private companies.
They're complete. It's just you think about company only 10 trucks. You go to them. Okay, show me your accounting balance, finance balance. That would be a little bit tricky.
Okay.
I had a quick question. Right at this is really nice. Right at the start, you had it's probably an unfair question coming from a psychologist to an economist, but you had a thing about dividing it into subconscious and conscious.
I was gonna say that word doesn't
I think
exist.
that 10 is subconscious.
So the first time I heard.
That's you catch me. I guess this is not. It's just economists kind of just not accurately using terminology in the front of I never got this is not a key thing, but I never got caught that by in a present. I guess I agree. This is not the psychology of the understanding of the concept of subconscious.
Yeah. Is it or do this thing absent-mindedly? You sort of distinguishing between switching on the AC versus stopping and taking a rest, or
no? I guess in my manner thing, they are all consciously. Subconscious meaning maybe you just do something. Maybe if you think about yawning itself as a way to just do that.
right?
As a subconsciously to just I feel tired, right? Just yawning. This is what I mean by
It's more of a physiological.
physiological.
I was wondering, do you track the nighttime temperatures? Because if they're sleeping in their trucks and it's really hot, like that might affect their performance in the day in terms of like driving and.
So that's actually meant to be more of an effect over the long term, isn't it? If heat is continuous and they don't have
That's a
respite.
great point. So sure, we have a separate paper on that, but this turned out to be very hard, even harder than this one, because technically speaking, for example, if you stop your truck in the parking lot, right, then you go back to your home. We do not know where is your home. We only know where is your kind of your park. So it could be some measurement error. So this is why we feel like this is not in the very beginning. We feel like kind of the heat induced sleeping kind of impair or like fatigue effect would be very interesting. But unfortunately, I feel we are not super confident that our data have accurately measured that. But I think we are not, to be fair, we are not terribly measured that, but we can in some measure that. But I feel like that would be much more better measured in the lab than in the field.